Tell you what, let's start this video out with a schematic of a radio. Even though we're working on the Halolight television, something came up from one of our good subscribers named Hugo. And the question he asked applies, I think, to both radios and TV. So let's throw a little something extra in here and try to help Hugo. He watched the Atwater Kent 145 restoration series that we did. And then he said, you know, I've got all the things I need to restore the one that I bought, the one that I have. And then he said, except, you know, and he said, I understand everything except for the complicated capacitors. Well, I wrote back and I said, well, what do you mean complicated capacitors? Where's the complicated capacitors? And he said, C9, C11, and C14. So I said, well, I'll tell you what. I will do a little video on this, and we'll cover, you know, a couple of these complicated capacitors for you and see if we can't straighten it out. And I'll do it on a video, you know, get everybody to see it. Maybe other folks can benefit as well. So I'll tell you what, let's start with C9. Let me get a pencil. Alright, here's the entire schematic. Now here's our cluster of three capacitors. That's C9. Up here is a cluster of two, or just two capacitors. That's C11. And then up here we have two more capacitors, which are C14. So let me go ahead and enlarge it. I just wanted you to see where they're located on the schematic. Let's go ahead and enlarge this baby. Let's start out with C9. Here we go. C9 is right over here. Let's go a little bigger. We'll take this baby up to 400%. This is a very good question, actually, because these three capacitors are probably located, I can't remember from what it was on my 145 that I restored, but I'll bet this was located in one little container. But that does not make it complicated. All you have here is three capacitors. Treat them individually. You know, cover this up. There you go. You've got one capacitor. One end is connected to ground right down here, okay? The other end, just get rid of those other two with your hand. One is connected to ground, even though they're located in the same container. It doesn't matter. They're side by side. One end is connected to ground. It comes around, it comes across, comes over. Let's find out where the other end goes. It goes up. Well, there it is. It goes up and it solders between these two resistors, R10 and R9. Right there's the connection. That was easy. Treat each capacitor individually. Don't look at them as a clump, okay? Let's go back over and do another one of these complicated capacitors. There's the second one right now. By the way, that's a 0.2 right there. This looks like a 0.05 and this looks like a 0.05. It's hard to tell. It's a little blurry. Let's take the second one. Again, don't worry about this capacitor on the right. Don't worry about that capacitor on the left. All three, by the way, are connected to ground on one end. Now, they could have put separate grounds for each one on the schematic, but they just put them together in one line and ran them all to ground. And, you know, no big deal. Now, come on. It's easy stuff. Nothing here is complicated. Trust me, especially on these old Atwater Kents. They're pretty simple. Okay, now we're going to go ahead. We're going to take a look at the center one only. We already did this one. We know it goes over between those two resistors. Now, this one here comes up. And on the chassis, it'll be connected to a blue wire at the opposite end. Of course, the black will be the ground. And it comes up, and it will go. Let's see where this one goes. Oh, look at there. It goes up to the screen grid of the 58 tube right there. There it is there. It comes out, comes down. Follow that lead. Now, keep your eye on that line right there while I scroll down. Scroll down, there it goes. The center one, it goes over to the cap, okay? And the other end of the cap to ground. Now let's go down a little further, see where else it connects. Alright, let's go down here, scroll it around. Down. There it is. It solders between R14 and R15 right there. Now that's not hard. Let's go back and look at the next one, the last one. This time, we're going to cover up these two capacitors and just go with this one. One end again is connected to ground. The other one goes up. The other end goes up and solders right here to the top of R4. Well, let's see what's on the top of R4. Let's see if we can get a little better landmark here. Ah, R4. It goes into this IF can right here. Okay? It will solder to the end that goes into that can. It'll be a white wire. It'll solder. There'll probably be a terminal here is what you're looking at. All of these where they solder in will be a terminal. Some sort of, you know, terminal where you run the wires to and solder it. That's it. That's the key to this whole thing. Treat each one individually. All right, let's go up and take a look. I'm going to take a look at one more set, and then we're going to go ahead and let Hugo figure out the last two on his own. Let's come over here. Tone control switch. Ooh, this is really fun. Tone control switch C14 is made up of a .001 and a .004 on the Atwater Kent 145. So we have both ends of each cap. They go down and they connect to the control grid of the 2A5. Pretty simple, really. Again, treat them individually. Let's take the bottom one first. The other end of the capacitor will hook to a yellow wire which hooks to the switch. There'll be a yellow wire coming off that switch on the Atwater Kent, okay? That switch will go to ground. Yeah, now, if that turns out to be a pink wire, it doesn't matter. It'll go to the switch that goes to ground, okay? Now, when this switch goes back and forth between the two, it'll throw this one in and take this one out, or throw this one in and take that one out. It doesn't matter. Whichever way the switch is thrown, okay, between these two right here. So both of them are grounded on one end. They're not grounded on one end. They're connected together on one end, and they go to the control grid of the 2A5 tube. All right, the other end goes to a black wire to the tone switch and a yellow wire to the tone switch. Handle each one separately. Don't get confused because they're in the same can. Not that big a deal. They just put them in the can for convenience, okay? You bet. All right, here's the last one, C11. You've got a cap here and a cap there. Two separate caps. I'll let you figure out how to do that based on what I've already told you. The key to it is handling each cap separately when you're putting it in the circuit, okay? Don't let these things scare you. There's no such thing as a complicated capacitor. Hope that helps, Hugo, and I hope the rest of you get a little bit of schematic help there also. All right, let's move on to the TV. So far, this is only the third television I've ever worked on in my entire life. The first one was a 1953 RCA, and the next one was a Silvertone, I believe it was. And now we have this one, the Halolight. And you know, I'm learning slowly but surely that, you know, no matter how you hook the components up, they all function basically the same. A tube conducts, a resistor resists, and a capacitor capacitances. Okay, all right. In the process of doing this, you have to have, if you're going to remove the chassis from the cabinet and then work on the chassis while it's connected to this picture tube, you got to have longer cables. They're called extender cables, okay? And of course, you know, we can't go downtown and buy them anymore like we used to many years ago, so you have to make your own. This is the first one I made. When I worked on that 1953 RCA, I got together with my mentor Brendan. I said, what do I do? He said, well, you got to build one. I said, well, hey, that thing's got thousands of volts in it. I said, I don't have wires that can handle, you know, thousands of volts. He said, well, what you got to do is you got to go downtown and get yourself a spark plug wire. A nice new spark plug wire. And then you got to take a safety pin. You got to cut it down so you can mount one of these little babies into one end. You cut down the boot. That goes to the plug wire. And then, you know, solder in this little baby because that's going to hook into the side of the CRT. The other end you'll have to cut down also and figure out a way to hook it to the wire coming from the flyback transformer. Well, this is the way I chose to do that. I cut it down and I put just a little fork thing, you know, a little connector fork thing in there, and I soldered them both in. They worked great. Now I had a nice long extender cable. Now why a spark plug wire? Because they can handle up to 20, 22, 24,000 volts. You didn't know it took that many volts to fire your spark plug in your car, did you? They sure do. But they're designed to handle that many volts, okay? So I just went to the auto parts store and I said, sell me a cable. And they did, the longest one they had. And I've used it ever since. So that was my first extender cable. CRT to the chassis. To the anode of the CRT. To the chassis on the side of the bell. The next thing I had to build, well, of course, was with this Halolight. I had to build a Yoke extender cable. So I just took a couple of connectors that I got and I fiddle-farted around, tore some stuff apart, and was able to build a Yoke extender. So now I have two cables that I can pull the chassis out of that Halolight TV and set it up on top of the TV. And I put a little blanket up there, or a rug or something. Brendan said they used to use blankets years ago. You could use anything that's soft, you know, not a towel. You want something a little thicker than that. And unless you get a couple of towels, you know. And this will help me extend the yoke from the back of the picture tube to the chassis once it's on top of the TV. Now, the last thing we have to have, I do not have an extender cable for the connector on the back of the CRT itself. And I have to build an extender cable for that. So that forced me to go out and buy one of these. This is called a television brightener, or a parallel. Let me zoom in here and give you a little closer look. This is a parallel TV brightener. I don't know why that's not focusing, but it's just not. Now I am upset with this camera. Oh, there we go. Okay, it's called a View Bright. There were different models. What does this thing do? Inside the barrel right here, this is the exact connector that's in the chassis. On the wire coming from the chassis, this is the exact connector that goes to the back of the picture tube. You know, that neck, you know, right on there like that. Inside here is a small transformer. That's all there is. And it would take the voltage to the filament on the picture tube. Take the voltage coming in on the pins. It would kick it up about 2 volts, send it down these wires, and send it into the back of the picture tube. They used them for weak tubes, okay? Those that didn't have, they weren't very bright. They were darkening up. And what would happen, it would, you know, kick the voltage up by 2 volts on the filament, cause the filament to glow brighter because it was getting more voltage. And what happens when the filament glows brighter? Well, it heats up the cathode even hotter. And when the cathode gets even hotter, then it puts out more electrons. And when more electrons start slamming against the back of the face of that tube, you know, on the inside of that tube, those electrons are just slamming now because there's a whole lot more going out. The picture gets brighter. The picture gets brighter. So that's why they called it a TV brightener. Now, how long do they last, though? I don't know. I've read on the internet where some of them lasted a month and some of them lasted 6 years. So I guess it all had to do with how often you turn your TV on and off. So why do I have this brightener? Because I need the connectors. I need the connector here and the connector here, so I can build a longer cable between them, so I can have an extender cable from the chassis to the neck of the picture tube. But I have to get rid of the transformer that's in there. So I'll tell you what, let's go ahead and open this up and take a look at the transformer. I'll show you what it looks like. I mean, that's what these videos are all about. Find out what's inside things. I love to tear stuff apart. Well, there it is, the little transformer. Isn't that cute? That's all it is. I just cut around the base of this thing with my pocket knife, cut through the glue that was holding that cardboard sleeve on. I may go ahead and reuse that cardboard sleeve, slip it back in there so I have, you know, like a handle to put it back on, or I just may decide to tape it. I don't know. I just kind of play this by ear as I go along. This is not something critical as long as the wires are correctly hooked up. Now these are color coded and the pins are numbered. The pins numbered there correspond to the pins numbered here, and they're the same as what's coming out of the chassis. All the wires are the same color. Go to the right pins, get them all lined up. Everything's good. It's all good. Well, here we go. Transformer's out. I'm going to go ahead and cut that wire right there, and then I'm going to cut off these two over here. Like so, and there we go. Alright, now all I have to do is cut between them. I was initially going to go ahead and extract all the solder from the pins, you know, with my Hakko FR300 solder extractor, and then just run wires from the end of here all the way down to solder them new in there. But you know, I think I don't want to do that. I think what I'm going to do, I don't want to disturb the existing solder there. I think it would be wise not to do that. So what I'm going to do is I'm just going to go ahead and cut the wires in the middle, and then run, you know, just lengthen them up with splices on each end, and heat shrink, and make sure that whatever's going to pin 10 on this one, whatever color wire is going to pin 10 here, is going to pin 10 over here. and pin 12 to pin 12, etc. Okay, back and forth, so they match up exactly. Now that may require me to remove one of these brown wires here. I haven't looked at it that closely. One of these two brown wires right here, I don't know. I need to eyeball it now, see what's going on, and then get started. I want to get that, you know, why am I doing all this? You know, why do I need to extend? Why do I want to put the chassis up on top of the TV and everything, and you know, leave it at it? Why not just keep putting it back in the cabinet? Because every time you do that, or at least in my case, every time I do that, I increase the risk of dropping that chassis, messing up, screwing up, and breaking the neck off the back of that CRT. You know, the odds get higher and higher that that's going to happen every time I keep messing around and messing around, putting in and pulling out that chassis. I don't want that to happen. That would be terrible. It wouldn't be the end of the world. I know where I can get another CRT, but I don't want to have to spend $140 for one. So anyway, let me go ahead and see if I can successfully pull off an extender cable here. Alright, let's do change number one. I'm always big on changes. I like changes. I like to be fluid, you know what I mean? Flexible. Yeah. And I decided to go ahead and remove the wires from this other socket anyway. I have the tools and I have the know-how, so why not just go ahead and do it? That'll keep me from having to solder wires twice, here and what would ever be sticking out of here. And then I have to put all kinds of splices on each one. This way all I have to do is splice one end, strip the other end, stick them through the holes and solder them in place. A lot easier. And these are the wires we're going to use. Color-coded to match what's coming out of this socket here that will be plugging into the back of the CRT neck. So hopefully the next time you see this, everything will be together and we'll have a nice long cable. Now there's one thing I want to point out here. I'm not going to take all these wires in one spot and splice them all at the same place. I get all done with the splices, I'll have a big lump right there in the middle of the wires, you know, like that. And that's not cool. I'm going to try to stagger them a little bit, you know, so they'll at least lay down somewhat when I put them together. You just don't want a big glob of wires all soldered together there and with heat shrink around them. It's just, well, it wouldn't be professional. Well, there you go, folks. It's all done except for putting some electrical tape around where I put the splices on. And what I did was I took some industrial heat shrink and put it, you know, every so often along here and shrunk it down. And then in between I put a little bit of electrical tape just to keep it together. You know, you don't want these, or at least I don't. I don't want this thing really stiff, you know, with so much coating on the wire that, you know, it's hard to bend and all that. It starts cracking after a while. I want it to be nice and loose and floppy, but I want it to be secure and held together well. So what I'll do now is I'll go ahead and put a little bit of, let me put a little bit of tape around these splices. Now I staggered the splices just a little bit. I wasn't able to stagger them as much as I wanted, but at least I'm not going to have a great big giant clump there, you know. And let me go ahead and get the tape on that, and I'll show you that. And one more thing, I'll probably go ahead and tape this cardboard also. This cardboard is, you know, I'm not going to glue it back in. I put a piece of heat shrink, industrial heat shrink on that up in there too, okay. Nothing to this stuff, nothing to it. So I'll go ahead and tape the cardboard to there. I like the idea of having a handle, you know, sort of a cardboard handle to work with. That's kind of cool. So I'll put some tape here and tape there. That way I can always open it up if I have to. Well, that's it, folks. We're all done. We got ourselves a nice, strong, sturdy handle to plug in with. And I left that part open down there where the wires go through. And we have this. And I got it all taped together. And I didn't want to use the industrial heat shrink on this. If I ever have to take it apart, I'd rather just, you know, unwrap the tape. And if it had this industrial stuff, I'd have to cut it off with a blade. You might wind up cutting the wires or whatever. We don't want to do that. You know, all I have to do now is just untape it. And if it starts to fray a little bit, I can just add a little more tape or remove it and put new on. This will do the job. This is the end of our extender cables. I think we're in pretty good shape now. The next video, we'll have the chassis sitting on top of the TV. And we'll have all of our extender cables hooked to it, and we'll get ready to stroke and poke after we've made the changes on the bottom of the horizontal output tube socket, okay? And anything else that might need to be repaired, we'll cover it at that time. So until next time, this is John.